you would like to start with? Or we go directly to section 8.1 and practice some more. Is there anything that you would like to try, or did you? Yes, please, Brian, go ahead.
Can we go over?
Yes.
5.4.
Which one?
5.4.
Yes. Which problem or problems?
The first one. Or not on this. I mean, like on the guided notes.
The one that we did in class?
Yeah.
Okay. Do you remember which one? Can you dictate it to me?
It was x squared plus y squared plus 5 and 3x minus y.
So this was 5?
Yes.
And?
3x minus y equals 5.
Okay. They're both 5? Okay. And today is the 19th. Very good. So this is a system of equations. Nonlinear. One of them is linear. The second one is linear. And the first one is not. Okay. So it is clear that we cannot use elimination. How come that I cannot use elimination? It's because this variable is x squared and variable is x. This is y squared and this is y. They're not the same. So I will not be able to eliminate. So my only option is substitution. So I will definitely solve this equation, not the first one, for either x or y. Which one do you recommend? Yes, because y has a coefficient of 1 or negative 1. So this is negative y equals negative 3x plus 5, and I have to multiply both sides by negative 1. Now, knowing this, in other words, knowing that y can be replaced by 3x minus 5, I go back to the first equation, and I rewrite x squared plus 3x minus 5, everything squared equals 5. Are these steps okay so far? Okay, now I have an equation in x. It is quadratic. All I have to do is combine like terms, move 5, and so on and so forth, and then use one of the 4 methods. Which 4 methods? Factoring, taking square roots, complete the square, never, and quadratic formula. When I square 3x minus 5, how many terms do I get? Yes, so this is x squared plus the first term squared, which gives us, very good, minus 2. It's wise to multiply 2 by 5 and get 10, and then by 3 and get 30, plus 25, and minus 5 equals 0. So far, so good? Everyone? Now, I have to combine like terms, and I have 10x squared minus 30x and plus 20 equals 0. It is quadratic, but I definitely want to make my life as easy as possible, which means what will I do? I will definitely have to, yes, divide both sides by 10. So then I have x squared minus 3x plus 2 equals 0. And if I can factor quickly, I will definitely factor. Otherwise, forget it. Use the quadratic formula. Can I take the square root from both sides? The answer is no, because it's not set up that way. I would have to complete the square in order to take square roots from both sides. Very good. X minus 1, x minus 2, and there are 2 options, 1 and 2. That's good, but it's not good enough. It's because I have to find the corresponding y value. Just x alone is not enough. So then, what do I get? When I plug in 1, I have 3 minus 5, which is negative 2. And when I plug in 2, I get 1. So now what are the ordered pairs, or the 2 points, if you want, that form the solution of the system? Perfect. 1, negative 2, and 2, 1. I have to go back and check. I have to go back and check back to the original system. Both equations must work. Otherwise, there is an error somewhere. Would you like to check, or you will check later? So we can move on to something else. We want to check now? Yes? Okay, so let's go back and check. So I check 1, -2, 1, -2, 1, -2. 1 plus 4 is 5. 3 plus 2 is 5. I'll say yes. Now I check 2 and 1. Let me use a different color. Let's say 2 and 1. 2 and 1, 2 and 1. 4 plus 1 is 5. Check. 3 times 2 is 6. 6 minus 1 is 5. Check. Is this better now? Good. Other questions? Anything you want? Anything that you worked on? Anything else? Any type of problem before we go back for a minute or two back to 8.1? Okay, so let's go back to sequences, 8.1. Okay, here's a typical example of a sequence. The first term, the second term, 3 dots, the nth term, and then 3 dots. This is an infinite sequence. And these are terms of the sequence. The terms of the sequence. A sequence can be given to us in 2 different ways. We're going to look here at 2 different ways. Sequence, general term, which means an. That's the general term. And I'm going to pick an example right now. Let's say on page 752, problem 10. We are given an, the general term, 3n over n plus 5. So a sequence can be given to us as a general term, or it can be given to us as a recursive formula. So here is an example like that. A1 is 7, and an, the general term, is an minus 1, the previous term, plus 5, for n greater than or equal to 2, and I copied problem 13 on the same page. So let's talk about it one more time. So a sequence can be given to us by simply specifying the general term. And we are given an, that's the general term, and this is given to us. An equals 3 times n over n plus 5. So in problem 10, let's see what they want. Write the first 4 terms of each sequence, whose general term is given. So we're given, one more time, 3n over n plus 5, and they want us to find the first 4 terms. A1, A2, A3, and A4. How do I get A1? Replacing n by 1. So it's 3 over 6, which is 1/2. How do I get A2? Replacing. Very good. So I have 6 divided by 7. How do I get A3? Plug in 3. How do I get A4? That's it. So 9 divided by 8 and 12 divided by 9. I can simplify the last one to 4/3. But I cannot simplify 9/8. Okay, let's see the other one. So a sequence can be given to us not by giving the general term, but by giving a relationship that includes the general term. This is what is called a formula, that it's a recursive formula. So still I'm given an, but not directly, right? It depends on the previous term. So in other words, if I have here a7 will equal a plus 5. Exactly. What about a10? A10 will equal a 9 plus 5. So I cannot determine 10 unless I determine the previous one. I cannot determine the 5th term of the sequence unless I determine the 4th one. I cannot determine the 4th if I don't determine the 3rd, and so on and so forth. So it's a recursive formula. We still have the general term, but given in an indirect way. Let's see what problem 13 is asking us to do. In 13, we want write the first 4 terms of each sequence. So I'm going to copy it here. A1 is given to us, but then thereafter we are given this. And we are told the formula is valid. Of course, I'm given A1, so I have to start with A2. So A1 is given. I need to determine A2, A3, and A4. But A2 depends on A1. So can anyone give us A2? So A2 will be 7 plus 5, which is 12. What about A3?
Why is that when we do 7 minus 1?
So when this is 2, this is 2 minus 1, which means A1, and A1 is 7. Better? So when I need to determine A2, I have to have A1 plus 5. When I determine A3, I have A2 plus 5. When I determine A4 is A3 plus 5. Is this better? So therefore, A2 is A1 plus 5. But A1 is given to us as 7. 7 plus 5 is 12. What about A3? A3 is the previous term plus 5. What is the previous term?
12.
So 12 plus 5 equals 17. And the last one, A4, is the previous term plus 5. So this is 17 plus 5, which is 22. Is this better? Let's choose another, just to make sure. Okay, so let's look at 18. Another recursive formula, a sequence given to us as A1 equals 5 and AN, the nth term, equals 3 multiplied by AN minus 1, and then minus 1 for n greater than or equal to 2. This formula, the recursive formula that includes or has the nth term, starts at 2 for n equal 2, as A1 was given to us. Again, the same question. We want to determine A2, A3, and A4. So one more time, when n is 2, this index is 2. This index is 2 minus 1, which equals 1. So it's 3 times A1 minus 1. Agreed? So 3 multiplied by 5 and minus 1, which is 14. Now A3 is 3 multiplied by the previous term, which I already determined, 14 minus 1. So 42 minus 1 is 41. Are we okay with this? Yes, everyone? So then 3 multiplied by 41 minus 1. Remember, you have to multiply first. So it's 123 minus 1, which is 122. Is this better concerning the recursive formula? Okay. And basically, that's all we needed to cover. but I would like to practice some more now with the factorial formula and a couple of examples, and finding the sum. Okay, so the next set of problems, 19 through 22. The general term of a sequence is given and involves a factorial. Write the first 4 terms of each sequence. So this is problem 20 on the same page, 752. And here is the general term. At the top, n plus 1 factorial and divided by n squared. This is not a recursive formula. It does not depend on the previous term. I'm given the general term now. So I need to identify or find A1, A2, A3, and A4. I have a tickle today. All I have to do is, in order to determine A1, I will have to replace n by 1. So how much is 1 plus 1? Okay, so that's 2 factorial. And 1 squared is 1. How much is 2 factorial? It's 2 times 1 over 1. So then the answer is 2. And this will not have any impact on the next, and the next, and the next, and the next. What about A2? What do I have to write for A2? 2 plus 1, which is 3. So this is 3 factorial over 2 squared, which is 4. So 3 factorial is 3 times 2 times 1 divided by 4. 6 divided by 4, 3/2. Sorry, I have to squeeze it in here. Sorry about that. A3. 3 plus 1. So it's 4 factorial divided by 9. Say it again. So the top is 4 times 3 times 2 times 1 divided by 9. I will simplify. That's the only thing I can do. So then the answer is 8 over 9. I have plenty of paper. I don't know why I squeezed this in right here in the corner. Sorry about that. Let me go to the next page. A4. A4 is 4 plus 1, which is 5 factorial divided by 16. But 5 factorial is 5 times 4 times 3 times 2 times 1 over 16. And this is an 8. So 5 times 3, 15 divided by 2.
Would the A3 is the A3 or the A9?
I'm so sorry, I forgot to turn off my phone. So if you hear something, disregard it. Forgive me. 4 times 2 is 8 over 3. Sorry. Thank you. 8/3. Thank you. Sorry about that. Yes, I wrote it underneath, but I copied something else. Thank you. Okay, let's also simplify some more factorials. Let's see problem 26. In problem 26, we're asked to simplify 20 factorial, and I want to show you how to do this with the graphing calculator as well. Okay. Here's what I would do to simplify this expression. The top is 20 factorial, the bottom is 2 factorial and 18 factorial. I'm going to ask a silly question. Which of these two, 20 or 18, is bigger? Of course. So instead of writing 20 times 19 times 18 times so on and so forth, I'm going to write 20 times 19 times 18 factorial. And now I'm going to ask another silly question. Why do you think I stopped at 18 factorial and not at 17 factorial or 15 factorial? Because there is an 18 factorial in the denominator. So this is 2 times 1 times 18 factorial, and these two go away. And then I'll simplify 2, and I'm done. Now, how will I do this with a graphing calculator? If you don't want to simplify, I highly recommend simplify. So the factorial symbol is in on the probability in the math. So 20, go to math, probability, PROB, and choose number 4, and divide by, in parentheses, 2 factorial, go back to math, go back to probabilities, and number 4. What did I do? That was really nice, but that's not what I wanted. Okay, so factorial. Whatever that was interesting. Okay, multiplied by 18 and factorial. Close the parenthesis. And when I hit enter, what should I get? Yes. Okay. Now, there are certain examples in which the calculator will not work. Why? Because the number will be so big, it will not be able to calculate. So simplifying the expressions with factorials is very important. Also, what if the expressions have variables? You will not be able to do this with a calculator, right? So let's choose one with variables, like, let's say 27. In 27, we have n plus 2 factorial divided by n factorial. Well, we cannot put this in the graph. Sorry. We cannot put this in the graphing calculator. And we will still be able to simplify it. Again, which one of these two is bigger? Is it n plus 2 or is it n? I know it's a silly question. N plus 2. So how will you write n plus 2 and not touch at all n factorial? Like with 20, I have to start with 20. N plus 2 times. Then I have to have the 19. How will I have the so-called 19 here? Very good. And then times? Yes, and I will stop n factorial because these two go away. So then n plus 2 times n plus 1 is n squared plus 3n plus 1. I'm sorry, plus 2. N squared plus 3n plus 2. And that's it. And let's find the sum, like 39. And then we can start reviewing. From I equals, so the sum from I equals 0 through 4. From -1 to I, power I, which is not the complex imaginary number, and over I factorial. So they're asking us to find the sum. Okay, so when I is 0, can anyone dictate? -1 raised to 0, how much is that? Any number raised to 0, except 0, which is 1. Very good. 1 divided by 0 factorial. So let me refresh your memory. 1 factorial is 1 as well as 0 factorial is also 1. This is by convention. And you can say, we've never seen this before. 2 different things to equal the same number. True. But this is the by convention. 1 factorial is 1 as well as 0 factorial. Okay, so this was the first term, plus. When I is 1, what do we have? -1 to the first power divided by 1 factorial, plus. When I is 2, -1 to the second power is? Very good, over 2 factorial, plus. When I is 3, -1 to the third, very good, over 3 factorial. And now I reached the upper limit. That's the last term I have to write. When I is 4, -1 to the fourth power is, very good, over 4 factorial. Yes, I have to finish this up. I have to find the sum. But first I had to list the terms. Since the lower limit is 0 and the upper limit is 4, I have to have 5 terms. 1 for 0, 1 for 1, 2, 3, 4. 0, 1, 2, 3, 4. Okay, good. So 1 over 1, this is 1. But then this is minus 1 over 1. Okay, these two are nice, go away. Plus 1 over 2 minus 3 factorial is 6, 1/6. And 4 factorial is 24. So 3 factorial is 6. 6 times 4 is 24. So plus 1 over 24. These two go away. So what we have is 1/2 minus 1/6 plus 1 over 24. 1/2 minus 1/6 plus 1 over 24. The least common denominator is perfect. So this needs a 12 and this needs a 4. So this is 12 minus 4 plus 1, which is 13 minus 4, which is 9 over 24, and simplified by 3, 3 over 8. Any questions? Okay, one last example here. Let's say 45. I think we did 45, but I'm not sure. 752. So we have 2 plus 2 squared plus 2 to the 3rd plus dot 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 plus 2 to the 11th. They want us to use the summation notation to express this. Not do anything with it. It says express each sum using summation notation. It says use 1 as the lower limit of the summation and I for the index. You don't have to use I. You can use K. You can use J. It doesn't matter. We can use J from 1 to whatever. It doesn't matter. The index is not important as long as we start with 1. So what will be the general term? In other words, I'm looking for an. Yes, 2 raised to I. In this case, that's J. And where does it go? From J equals 1 till J equals, that's it. That's all we're asked to do. So now let's take a look at, this is the end of the material. I just wanted to practice more from 8.1. Ready? You guys just start. They're pretty similar, very, very similar. It doesn't matter. So this gives you more details on what I'm expecting, and this one does not. We can start from the end, because this will take us very little that we just did today, those last problems. And we can work on the Gauss-Jordan method, and then work our way backwards. Or you can say, no, I want to start from the very beginning. It's up to you. I'll do whatever you want me to do. Whatever makes you comfortable. You want to start with the end, with the second form. You want to start with the first form. You want to start from the beginning. You want to start from the end. It's up to you.
I say we start with the Gauss-Jordan problem.
Very good. Awesome. So let's see which one. There must be one here. Okay, right here. Very good. So let's start with that. Perfect. There are two. They're different. So we can do one, and then you can work on the other. Okay. So which one you want me to do, and which one you want to work on yourselves on your own. This one from 23 or this one from 18? It doesn't matter really. Any preference? So you want to do 18 with me? Okay, so let's do 18 together. So in 18 we have good. So where is the starting point? what do we have to write first when we try to solve the system using Gauss-Jordan? First of all, remember, all x terms have to be one under the other, the y terms, the z terms, the equal symbol, the free terms. If they're all intertwined or all over the place, we have to rearrange the system like this first. So where is the starting point?
The first x.
Right. So first I have to write the augmented matrix. So without having the augmented matrix, I will not be able to get the method started. So the coefficients, 1, 1, 1 for x, 1, negative 1, negative 1 for y, and 1, negative 1, 1 for z, and the free terms after the vertical bar that really represents the equal symbols, and 9, 1. So again, if we deviate from the system, from the steps, we will not be able to solve. Do not try and say, oh, I'm going to do something else. It's not going to work. So the first step must be this, and it is. It's lucky it's already in there. If it weren't, I may have had to divide both sides by 2 or swap the rows, who knows, okay? Now I have to get a 0 here and a 0 here. Obviously, I have to use row 1. Multiply it by something and add it to row 2 and respectively to row 3. Yes, in both cases, I have to multiply by negative 1. Please do not put the equal symbol between matrices. That would be incorrect. It's an arrow. They're not equal. Good. So now the next step. I do copy the row that does not change. And of course, in the first step, it has to be the first row. 1, 1, 1, negative 5. The next step. Carefully multiply. Let's do it together. Remember what we are trying to do. We will be multiplying everything in this first row by negative 1 and adding it to the corresponding terms like we did the elimination. Identical step. 1 times negative 1 plus 1, 0. 1 times negative 1 minus 1, negative 2. Very good. 1 times negative 1 minus 1, negative 2. Negative 1 times negative 5 is 5 plus 9, 14. One times negative 1 plus 1, 0. 1 times negative 1 minus 1, negative 2. 1 times negative 1 is negative 1 plus 1 is 0. Negative 5 times negative 1. 5 plus 1 is 6. Although you have to be very careful at each step, you always remember, at the end I'm going to check the solution. If it doesn't work, I don't recommend trying to go back and fix and find the error. Start from scratch. I would recommend on the test, leave this problem at the very end. It's going to be just one problem. It's not going to be 100 points, worth 100 points. So do everything else, because if you make an error and you get upset, then you may be upset for when you work on other problems. Okay, it's very easy to make an error here. So I'm going to check. 1 times negative 1 plus 1 is 0. This is negative 1 minus 1. That's correct. This is negative 1 plus 1 is 0. And this is 5 plus 1 is 6. Okay? This is my suggestion. Now, if you're very comfortable and you work on these problems and you did, I don't know, 10, 15 problems, it will not take long. So you can, but don't get upset if you don't get the correct answer the first time. Move on to the next problems and then come back. Okay. Obviously, I have to work on this. It's okay to divide both sides by negative 2. It's also okay to swap these two and divide by negative 2 because you already have the zeros. It's up to you. So you can swap and then divide, or you can say, forget it, it's okay, no problem. I will divide both sides by negative 2 to get my 1. If I don't get the 1 here, I will not be able to get the zeros. This number has to be 1 that will enable me or help me get the zeros here. If I don't get the 1 here, I will not be able to get the zeros. So you want to divide both sides as is? Yes? Is it a yes or no? Okay, so then R2 divided by negative 2. I copy R1, 0, 1, 1, negative 7, 0, negative 2, 0, 6. So what did I accomplish so far? All this is done, and I have the next step. Now this number, this one will help me get the zeros. So of course I will be using now row 2 twice. First I will add it to row 1, and then I will add it to row 3. But now the question is, what do I multiply row 2 by to eliminate this number? Perfect. What do I multiply this one to eliminate this number? By 2 indeed. Your book does not show 2 steps in one. I recommend 2 steps in one because otherwise it will take you 3 pages. If you do first the row 1 and then you come back and do row 3 and then, you know what I mean. So your book does not show 2 steps in one. I recommend 2 steps in one. Otherwise the method is really long. So which row do I copy now? Because I know for sure it's not going to change. Yes, because it's the one that I use. And it cannot change while I use it. One times negative 1 plus 1. Of course. 1 times negative 1 plus 1. Lucky me. Negative 7 times negative 1, which is 7, minus 5. Perfect. Next one. 1 times 2 minus 2. 1 times 2 plus 0. Negative 7 times 2. Negative 14 plus 6. That's it. What did we accomplish? A lot. What do I do next? Without which I can't continue. Yes, I need a 1 here. Obviously, I have no choice. I have to divide row 3 by 2. So 1, 0, 0, 2, 0, 1, 1, negative 7, 0, 0, 1, negative 4. I have only 1 step because lucky me, I got a 0 here. I only have to worry about this number. So obviously I have to multiply row 3 by something and add it to row 2. What do I multiply row 3 by and add it to row 2 to eliminate that 1? Yes, negative 1 indeed. So that's the final step. 0, 0, 1, negative 4. Notice that I copied the third row because I'm using it. I have no choice. And I also copied the top row because it's already done. 1 times negative 1 plus 1 is 0. Negative 4 times negative 1 minus 7. And now I have the solution. Do I know whether it's correct or not? No, I don't. Not yet. I have to go and check. So what is the solution? The test on Monday. And yes, we will review. I'm sorry?
This is already posted. Like
Yeah, yes, yes. So what is the solution? Yes? I have no idea. It's so easy to make an error. So I'll go back to the original problem. Here it is. And replace 2, negative 3, negative 4. 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 And I hope for the best. 2 minus 3, negative 1. Negative 1 minus 5. Lucky me so far. 2 plus 3 is 5. 5 plus 4, because this is negative negative, so it's 3. That's 5 plus 4, 9. Excellent. 2 plus 3, 5 minus 4, 1. I don't need anyone to say anything, because I went back, I checked in all equations, it worked. It cannot be another. And I don't need anyone to tell me whether this is correct or not. Now, would you like to work on the other one? On your own? So we can put this aside, or you can say, no, I would like to continue reviewing. Continue reviewing, yeah? Okay? Good. So let's see from 24. In 24, we are given a general term. This is not a recursive formula. We're given general term, and we're asked to find 4 terms. Can we find the first term? Can you tell me what is the first term? So we have an equals negative 1 raised to n plus first power over 3 to the n minus 1. Brian, are you working on the previous Gauss-Jordan?
No, it's just before
I mean, if you want, I can wait.
I'm on this one.
So we want to look at 24. So we're asked to find A1, A2, A3, A4. Can anyone dictate the preliminary for A1? Don't calculate anything, just dictate A1. Negative 1 raised to, very good, over 3 minus 1. The top is 1, the bottom is 2. This must be the first term of the sequence. A2. Negative 1 to which power? Very good. Divided by 3 squared, which is 9 minus 1. The top is negative 1. The bottom is 8. This is the second term of the sequence. A3, the top. Negative 1 to the, good, 3 to the third, 27 minus 1. So 1 over 26. Final term, negative 1 to the fifth over 3 to the fifth, I'm sorry, 3 to the fourth minus 1. So negative 1 at the top, 81 minus 1 in the denominator, negative 1 over 80. This was 24. Now 25, this is a recursive formula. We are given A1 equals 4. We are given an equals 3, an minus 1 plus 3. Of course, this is valid only starting with 2. And it says, write the first 4 terms. Can anyone give us A1? Exactly. Can anyone get us started on A2? 3 multiplied by, yes, plus 3. 12 plus 3 is 15. Agreed?
So A minus 1 just means the previous time.
Exactly.
Okay.
So if it's the previous before this one, there will be an minus 2. If it's the previous before that, will be an minus 3. So 3 multiplied by 4 plus 3. 12 plus 3, 15. Marcus, okay? Is that okay? Clear? So this, when we're talking about 2, 2 minus 1 is 1, which is 4. A1 is 4. Okay, so A3. 3 multiplied by, yes, plus 3. Remember the order of operations, 45 plus 3. And the last one, A4. is 3 multiplied by 48 plus 3. I got 147, correct me if I'm wrong. Evaluate the factorial expression. Ready? Any questions on this? N plus 1 factorial over n factorial. Which one is bigger? Because I can't put this in the calculator.
+1.
So it's n plus 1 times n factorial over n factorial. So it's n plus 1. One plus 3 plus 5 plus dot 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 2n minus 1 equals, use any index you want. It can be k, I, j. Let's use k this time. Express the sum using summation notation. So we need this, and we need this. Obviously, this must be the general term. This must be the 2k minus 1, no doubt. From k equals, let's see how we get this term. What should I put here that I replace k by in here to get 1?
0.
If I put 0, I will get negative 1. 1 indeed. Let's check. 2 times 1 minus 1. When k is 2, I should get this term. Let's see. 2 times 2 is 4 minus 1. Do I get that one? When k is 3, let's see if I get this term. 2 times 3 is 6 minus 1, 5. Correct? When k is, to get this. 2 times n minus 1 is that. That's it. And the last one here was we were asked to evaluate this. Since the denominator does not have factorials, I'm not going to mess with it. I have to put it in the graphing calculator. It shouldn't be, it couldn't be nice, I don't think. So we'll see. So we have at the top 40 factorial, math, probability, and 4, and divide by 450. That's all I can do. And I get something horrible. 1.8131 times 10 to the 45th power. 1.813 times 10 to the 45th power. Because of that 40 factorial, which is huge. So please be careful. So you read the entire number. If you see an E45, means 10 raised to power 45. Okay, so this, let's go back now. So let's take a look. Graph the solution set of the following system of inequalities. That's our next problem. Solve the system. Find the length and width of a rectangle whose perimeter is this and whose area is this. So you tell me what you would like to continue with, and let's choose.
You start with 1.
Which one?